Projectile Motion Series, M&M Quiz 2154. Welcome to He Can Help. Again, we have a velocity vector of 40 meters per second at an angle of 60 degrees with respect to the horizontal. Assume no air resistance. Positive x is defined as to the right, positive y is vertically up. So a projectile is launched at 60 degrees with respect to the horizontal. The initial velocity vector makes an angle of 60 degrees with respect to the horizontal. What is the vertical component of the velocity vector after 2 seconds? Is it A, or is it B, or is it C, or is it D? So by definition, the average acceleration along the vertical, y, is vertical, and that is given by final velocity along the vertical minus initial velocity along the vertical. Initial is v0 and the vertical is y. So final velocity along the vertical minus initial velocity along the vertical, you're talking about vertical components, okay, divided by total divided by time. The acceleration along the vertical is negative 9.8. We don't know what the final velocity along the vertical is. We know the magnitude of the initial velocity vector, and that's 40 meters per second. And from that, based on what is given, the angle, based on the angle that is given, we can find the horizontal and vertical component. The horizontal component is 40 cosine 60. The vertical component is 40 sine 60. Please don't forget sine theta. For our case, theta is 60. Sine theta is opposite side to theta divided by hypotenuse. So negative 9.8 equals final velocity along the vertical minus initial velocity along the vertical. Initial velocity along the vertical is 40 sine 60. And this whole thing divided by time. Time is 2 seconds. You cross multiply, and so you get negative 9.8 times 2 is equal to Vy minus 40 sine 60. Add 40 sine 60 to both sides. And what do we get for the y component? You get 15.04. 15.04. So what is the magnitude of the vertical component of the velocity vector after 2 seconds? 15.04. What is the direction? Positive. Positive x, positive y. What is it? Positive y. It's vertical, y. So positive y. Is it on its way up or is it on its way down? Because it is positive, and because we have defined positive x as to the right and positive y as vertically up, we have to think of this as still climbing up. So it is on its way up. Please don't forget, for the trajectory, if it is moving from left to right, at this point the x component is this way, y component is pointing up. At this point, the x component is still the same, but the y component is now pointing down. So that's what I did here along the vertical. You have acceleration is equal to change of vertical velocity divided by time. Acceleration along the vertical is negative 9.8. Initial vertical velocity component at t is equal to 0 seconds is given by 40 times sine 60, and that is 34.64 meters per second. Final vertical velocity component t is equal to 2 seconds. We don't know. We do not know. What is the time? 2 seconds. Substitute the numbers. What are the numbers that we can substitute? Remember, ay equals v final y minus v initial y divided by time. We know ay, we know time, we know v initial y. The only unknown is v final y. And don't forget, this is the same equation as what you have learned as V final is equal to V0 plus AT. So acceleration is change of velocity divided by time, and so you get acceleration is change of velocity is final vertical velocity component minus initial vertical velocity component, and that is what this is all about. And that whole thing divided by time, and that is equal to acceleration along the vertical. Acceleration along the vertical is negative 9.8. We don't know what the final vertical velocity component is, so we keep it as an unknown. The initial vertical velocity component is 34.64. Please don't forget, it is 40 sine 60. And divided by time, which is 2 seconds. You cross multiply, you get 2 times negative 9.8, and that is negative 19.6 is equal to Vy minus 34.64. Add 34.64 to both sides, and you get the final vertical component after 2 seconds to be equal to 15.04. Note that it is positive. That means what? It is on its way up. And wow, this is George Mathew signing off. Good luck. I need a coffee break.